he is noted for being the first to use telescope to observe the night sky. He didn't invent the telescope. The telescope, or effectively the optical setup to be able to see objects at great distance, was invented by Dutch opticians. Basically the word spread around very quickly. There was at the time a conference in Holland settling the peace between Spain and Holland, Spain used to occupy that part of the Europe for a number of years. And the word spread around rather quickly about this new device. And Galileo heard about it, and being very capable and energetic as he was, he said, well, I can make one myself, which he did. But what distinguished him from the others was that he turned it to the sky and did the observations of different things in the night sky. And his findings were staggering at the time. And I will list his most important findings. The first and foremost was that he observed that the Venus, the planet Venus, displays all the phases, just like our moon. And that finally proved that the heliocentric system was the correct system, not the geocentric model. Of course, you can imagine, and at the times when both churches, the Catholic and Protestant, were insisting on Aristotelian view of the universe with Earth at the center of everything, and you could lose your life for trying to challenge that view, all of a sudden this was just sent the shockwaves. Okay, and let me explain. So you see, you didn't need really stellar parallax. That was always used as an objection against this heliocentric model to actually show that the heliocentric model is correct one. Let me explain. So what you have here on the left is the universe according to geocentric model. The Earth is at the center, and everything else involving the sun revolves around it. Right? So do the planets, but they move along these circles whose centers also move around the Earth. That was Aristotelian or Ptolemaic view of the universe. So the sun revolves around the Earth, and also the planets move along these smaller circles, and the centers of these circles move along the bigger circles around the Earth. If this was the case, as you can see here, all we could ever see would be the crescent phases of Venus. All you can see, if this was the case, just a corner of Venus being illuminated by the sunlight. So if geocentric model was correct, all we could ever see would be the crescent phase of Venus. But he saw that Venus displays not just the crescent phases, but also the two quarter phases and the gibbous phases. And that can be understood only if Venus and the Earth revolved around the sun. Okay? Then we would see the crescent phases of Venus when the Venus is nearly between the sun and us, right? Because only a part of its surface that is illuminated by the sun is visible by us. But when it is here or here, so that these are right angles, we would see the first and the third quarter. And this part of the trajectory, when the Venus is basically on the other side of the sun, so to speak, we would see the gibbous phases, when more than half of its surface is illuminated. Okay? We, of course, could never see the full Venus, because then sun is between Venus when it's here and us. But we can certainly, as it moves in this direction, its gibbous phase grows, right? So here it would be waxing, here it would be waning gibbous phase. So from this observation by Galileo, it was clear what's going on. Okay? This observation, that we can see all phases of Venus, not just the crescent, but the two quarters and the gibbous phases, could only be understood within the heliocentric model. If the geocentric model was correct, all we could ever see would be the crescent phases of Venus. Okay? That was the final proof. As I said, the actual stellar parallax was detected, but much, much later, in 1832, I believe, or something like that. And people realized long before that actually the planets revolve around the sun, and not that everything is revolving around the Earth. And this observation by Galileo finally nailed it.